Hi, everyone. My name's Nicole Miner. I'm from the Exploratorium in San Francisco, and we are really excited to be coming to you live from JPL, which is NASA'S Jet Propulsion Laboratory in Pasadena. Today is a great day. They are about to land a lander on Mars. So this is going to be a lot of fun. We're here because the control room for the mission is here at JPL. You can actually see a picture of it here next to me. Things are a little bit quiet in there. All those people are monitoring the data. So stay tuned. We'll go to that cut soon. Today's the first landing on Mars in 6 years. InSight will be landing today. And 6 years ago in 2012, Curiosity rover landed. So it's been a while and things are really exciting. InSight is going to be studying the heartbeat of Mars, so learning about its interior. Let's go to a video now so you can learn a little bit more about this mission. InSight is a Mars lander designed to study the inner space of Mars. InSight carries a seismometer that measures the seismic waves created by Mars quakes. Its measurements will provide a glimpse into the planet's internal activity. This will be the first mission to pick instruments off the deck of a lander using a robotic arm and placing them on the surface of Mars. There is a wind and thermal shield that will be placed on top of the seismometer to protect it. It will also have a heat flow and physical properties probe, HP cubed, which will penetrate into the Mars surface about 5 meters or about 16 feet to take the temperature of Mars and help determine what the source of the heat is. InSight's rotation and interior structure experiment uses a radio on the spacecraft to measure small variations in the wobble of Mars' North Pole. These observations will provide information on the structure and composition of its core. InSight's primary mission is 2 Earth years, or a little over 1 Mars year. Can you tell us a little bit about why studying Mars is important and what we can learn about both Earth and our solar system from studying Mars?
Sure. So every time we go to another planet, we learn something about our own planet. And, Mars is just the right place to learn about the very early evolution of planets. One of the big questions that we'd all like to understand is, what makes a planet habitable? So far, we have Earth, the only planet we know of for sure that has life. And we think we understand some of the ingredients that are required, an ocean, water or an atmosphere, and volcanoes that actually produce that atmosphere, and a magnetic field that shields the surface from radiation. So we think those are some of the key ingredients, and we believe Mars had those very early in its evolution, the first billion years. So Mars is a great place to study that really early environment because on the Earth, we've had plate tectonics, which we have subduction zones that take the crust back into the interior. We have new crust that forms. So basically on Earth, that very early crust, it's totally gone. It's been recycled and churned around, and so we don't have very much record at all of that first billion years on Mars, on Earth, but we do have it on Mars. And so Mars is a great place to study that early part of the solar system. And InSight, by looking into the interior of Mars, we actually go back in time to the very birth of the planet, so we can really understand what the physics and chemistry were in that early part of the history. And today, it's just kind of all hitting me that this is the culmination of, decades of work on my part. Just hundreds of people have worked on this mission to bring it together, and and we're kind of standing on the backs of all those previous Mars missions and all that exploration. So it's really just this enormous event, and I will be very relieved and thrilled when when our lander's safely on the surface.
Thank you so much for talking to us today.
My pleasure.
Okay, we're going to take it back to the control room.
Science reports dropping carrier power as
Tom,
expected.
Marco A and Marco B have telemetry.
Hi, if you're just tuning in, we're back here at JPL Live for the InSight Lander mission landing. Things are getting closer now. Landing on Mars is really hard. We've only had about 40% success rate for missions to Mars, but NASA has had a really strong track record, so we're feeling good about everything today. I think you just saw some applause in the control room. The atmosphere is really thin on Mars, which is one of the reasons that it's difficult to land. It's only about 1% of Earth's atmosphere, which means there's very little friction, so it's hard to slow down the spacecraft. That is why they call it the 7 minutes of terror. In this case, it's 6 minutes and 45 seconds. So we're going to learn a little bit more about landing and all of these challenges. Let's take a look at this video. InSight launched from Vandenberg Air Force Base in California on May 5th, 2018. For the past 6.5 months, it has been cruising through space, traveling over 300 million miles, and today, if all goes as planned, it will land on the surface of Mars. About 7 minutes before arriving at the top of the atmosphere, the spacecraft will separate from the cruise stage and orient itself so the heat shield is precisely facing in the right direction. It will then hit a target point at the top of the Martian atmosphere at about 6 times the speed of a high-velocity bullet and will begin a process known as entry, descent, and landing. The heat shield will experience temperatures well over 1,000 degrees Celsius. Over the next few minutes, it will deaccelerate from about 13,000 miles per hour to about 1,000 miles per hour. At about 10 miles above the surface, a supersonic parachute launches out of the back of the spacecraft. It releases the heat shield and it will deploy its 3 legs designed to absorb its impact upon landing. At about a mile from the surface, the lander falls away from the back shell and lights its engines. The last thing that has to happen is that at contact, the engines have to shut down immediately so the vehicle does not turn over. 16 minutes after that, letting any dust from the landing settle, the fan-like solar panels that are especially designed for Mars' weak sunlight will deploy. So could you tell us a little bit about what's happening today in the landing sequence? What's happening in the control room? What are all those people doing?
Okay, yeah, so basically right now we have a whole team in the control room looking at data coming down from the spacecraft. One of the interesting things, however, is that when we're looking at data coming down from the spacecraft, that data is actually already 8 minutes old. So it's data coming from the past, because when you get radio signals coming from InSight, Mars is so far away that even though the data is traveling at the speed of light, it takes 8 minutes to get to Earth. So when we're landing on Mars, when we get data in the control room of that first signal that we're entering the Martian atmosphere, InSight is actually already going to be on the surface of Mars. It'll either be in one piece or multiple pieces, but it's already going to be there.
What kinds of adjustments are made for landing, and how much of it is automated, and how quickly does that happen?
Okay, so we've been doing adjustments for landing since the day we launched. So when we launched, the rocket gives us, gives us speed. We're going generally towards Mars, right? And we had things called trajectory correction maneuvers. So we've actually had 5 of those, with TCM6 being the last one that happened the day before landing. Now I said TCM6 and I said 5 maneuvers. I do know how to count. We skipped one. We actually skipped TCM4, I believe, because we were just going in the right direction and we didn't need to do that correction maneuver. And each time we do a correction maneuver, we're basically just adjusting the direction we're going in so we can target the exact spot that we're landing on Mars. So that last TCM6, we basically were just looking at exactly where we'd like to go on Mars within a few kilometers. And the other thing that we adjust is we've been looking at weather. Basically, we've been monitoring the weather on Mars, and depending on what we were looking at, we would have adjusted different entry, descent, and landing parameters differently. We have a clear day today on Mars, no storms, it's a beautiful sunny day. So we adjusted the parameters to deal with that kind of environment.
Okay, we're going to take it back to mission control.
InSight is now traveling at 1,000 meters per second. Once InSight slows to about 400 meters per second, it will deploy its 12-meter diameter supersonic parachute. The parachute will deploy nominally at about Mach 1.7. Standing by for parachute deploy.
Radio science reports sudden change in Doppler.
Ground stations are observing signals consistent with parachute deploy.
Marco Alpha, Marco Bravo, maintain lock status.
Telemetry shows parachute deployment. Radar powered on. Heat shield separation commanded. We have radar activation where the radar is beginning to search for the ground. Once the radar locks on the ground and InSight is about 1 kilometer above the surface, the lander will separate from the backshell and begin terminal descent using its 12 descent engines.
Hi, we're back, and if you're just tuning in, things are getting really exciting here. The parachute deployed and the heat shield separated, and we believe that the radar is now working. So things are really heating up, as they say. We just wanted to let you know that the landing site that they've chosen for the lander is called Elysium Planitia, and it's nice and flat. It's a parking lot. Things are sort of happening in the control room, so we're going to want to go back there. If you're having any trouble with the audio there, just know that that's NASA's trying to fix it. But let's go back to the control room. It's really exciting.
Altitude 400 meters, 300 meters, 200 meters, 80 meters, 60 meters, 50 meters, constant velocity, 37 meters, 30 meters, 20 meters, 17 meters, standing by for touchdown. Touchdown confirmed. InSight is on the surface of Mars.
Hi, everybody. So that was really exciting. Touchdown has been successful. I'm sure you can see all the mission staff are so excited. There's a lot of handshaking, a lot of high-fiving. So we're really excited here. I just wanted to tell you a little bit about what's coming up next. InSight is going to take a lot of pictures, which the scientists and engineers are then going to use so that they can determine the best place to put down the instruments. This whole process from landing to deployment of the instruments is going to take about 2 to 3 months, and then the data will start coming in. You might also be wondering about the images. When will we get some images from Mars? So one exciting thing is that there's a new technology that traveled with InSight on the rocket. They're 2 little CubeSats called Marco, and Marco may have been able to take a picture of the landing if everything lined up right, and we should know that in the next 10 to 20 minutes. If we get that image, we'll post it on our Facebook page. So let's learn a little bit about Marco, because Marco is really exciting and everybody should celebrate because InSight has landed on Mars.
When I was growing up, I didn't have a role model who was an engineer and a woman of color. So for me, it's really important to give back. My name is Farah Alave, and 3 of my spacecraft are currently on their way to Mars. I don't think I'd ever even dreamed of doing that. This is the work area for Marco. This is where we built the spacecraft. Marco is a pair of very small spacecraft that are going to Mars to do entry, descent, and landing telecommunication relay for InSight. That's InSight right here, and so that's the signal from InSight, and this is us transmitting back to Earth. Basically being that cell phone tower that repeats the signal coming from InSight down to the ground. So you have the propulsion system. For InSight, we're not relying on Marco. It's just demonstrating a technology. We've never launched CubeSats to outer space before, but if it works, then in future missions, we can start relying on them. We run everything that we're going to do on the spacecraft on the ground first. One of the things that really drives me is no one has ever done this before. We're just breaking ground and exploring our solar system. It's just so exciting.
Hi, everybody. So wasn't that amazing? Marco is pretty cute. I'm hoping, really hoping that those images come in. So please stay tuned with us. Check back on our Facebook page. I know there's a lot of celebrating going on right now in the control room. We want to thank you for tuning into our broadcast today, and we'd really like to thank our partners at NASA and JPL for making this special access for us and all of our viewers available. Please come back and check us out on Facebook or on the Exploratorium website, and we'll keep you updated on the mission in the next few months ahead. Thank you so much, and goodbye for now.